All right, guys, before we get started, are there any questions over the homework? Questions over the homework assignments? Yep. All right. What we're looking at today and going over today is complex numbers. Our complex numbers with addition, subtraction, solving, different properties. So the imaginary number I is really just our square root of -1. And it's also good to note or understand that I squared is -1. And we need this to solve quadratics, especially when it does not cross the x-axis. Because if it's not crossing the x-axis, we end up taking the square root of a negative number, and we can't take the square root of a negative number. So that's where our imaginary unit I, or imaginary number I, comes in. Now, by adding real numbers to, real numbers are real multiples of the imaginary unit, we get a complex number in the form of a plus bi. So in standard form, we write it at a plus bi, where a is the real part and bi is our imaginary part. For instance, -5 plus the square root of -9 is really -5 plus 3i, because we can reduce the square root of -9 as I, the negative comes out as I, square root of 9 is 3, giving us this here, and that would be in standard form. So if we're looking at standard form for these here, 4 is already simplified, but we do need to simplify the square root of -49. Now the negative is going to come out as I times our square root of 49. And the square root of 49 is 7. So we get 4 plus 7i. Our real part of this is going to be 4. The b value is I, because if we're relating this to a plus bi, our a is our 4. Our b would not be I, it'd be our 7. Because a has been replaced with 4, b is replaced with 7. A plus bi. Let's look at 2 minus the square root of -18. 2 minus, well, the negative, again, is going to come out as I, leaving us with I times the square root of 18. Now, we need to make sure that the square root of 18 simplifies as far as possible. Now, there is a number that multiplied by itself that will give us 18. So we do have to reduce that radical. One of the ways is we can use the 30xs and tell it to take the square root of 18. Let's see here. Okay. Try that again. Second square root of 18, because it's going to look for perfect squares that it can pull out. Notice it's 3 square root of 2, or in our case, 3i square root of 2. And that would be the final answer. Because what the calculator is really doing is looking at 18, square root of 18, which would be the same as 9 times 2. And we pick 9 because 9 is a perfect square. Square root of 9 would be 3, leaving us with our square root of 2. And square root of -18 would be 3i, square root of 2. Questions on this so far? Definition of a complex number. Complex number contains 2 parts, the real part A and the imaginary part bi, where b is still a real number. So we get a plus bi. So the set of real numbers is a subset of the complex numbers where we have our real and imaginary parts that combine to give us our complex number. So two complex numbers, a plus bi and c plus di, when written in standard form, are equal to each other, where a is equal to c and b is equal to d. And really, we can figure out what a and b's values are from any given equation. So if we're looking at this here, we're saying that a minus 2, this is our real part. And it's going to match up to our 6. The bi part is going to be the number in front of I. So really we're saying here that a minus 2, when simplified, should give us 6. And the b plus 1, when simplified, should give us 5. So here we can add 2 to both sides, telling us that a is 8. And b is 4. So we're just matching up the two sides of the equation to see what's going to take A's spot, and what's going to take B's spot, and compare those together. Questions on this here? Operations with complex numbers. To add or subtract two complex numbers, you add or subtract the real parts and the imaginary parts to each other. And we've done this before. So if we're looking at 4 plus 7i plus 1 minus 6i, well, we can drop the parentheses and add our real parts together. Well, what is, the real numbers are 4 and 1. 4 plus 1 is what? 7i minus 6i. That's it. Two plus, or 1 plus 2i plus 3 minus 2i again. Just like before, we can drop the parentheses and combine like terms. 1 plus 3 is 4. 2i plus negative 2i is 0. So it is just 4. Questions on these here? And again, we can keep doing these by hand. We drop the parentheses, distribute the negatives, and it'll get us to our answer after we combine like terms. Now, one of the nice things with the graphing calculator is that it will let us type in terms with I. So, 5. It'll tell us that this here is negative 5i. And we can verify that pretty easily. So again, the first thing we can do is drop the parentheses. Now for the first one, we're going to, well, for both of these, we have to distribute that negative through. So negative 2 becomes positive 2. Positive 3i becomes negative 3i. Positive 2 here becomes negative 2. Positive 5i becomes negative 5i. Here are 2 minus 2 is going to be 0. 3i minus 3i is leaving us with negative 5i. Even this next one, we can do it in the calculator or we can do it by hand. And if we do this by hand, the first thing, again, we have to do is distribute or simplify these parentheses. First set of parentheses here we can just drop. Same with the second set. But with the third, we do have to distribute that negative, giving us negative 7 minus I. And again, at this point, we can combine like terms. 3 plus 4 is 7. Minus 7 would give us 0. 2I minus I. Minus I is 0. Everything ended up canceling out. Yeah, because 2I minus I would be 1. 1I minus another I. Yeah. Yeah, this whole thing ended up being 0. So, many of the properties with the real numbers are valid for complex numbers as well. So we can associate. We can do our addition and subtraction. We can also do distributing. We can multiply through. That means we can multiply through with our real numbers or with complex numbers. So here we can use the distributive property to multiply through. 4 times negative 2 would be negative 8. 4 times 3i would be plus 12i. And that's it. On our second one, we can do the distributive property again. But this time we're going to have to do it twice. 2 times 4 is going to give us 8. 2 times 3i is going to give us plus 6i. Negative I times 4 is going to be negative 4i. And lastly, negative I times 3i is going to be negative 3i squared. Now at this point here, we can start combining like terms. 8 doesn't have any like terms, but our 6i minus 4i is going to be plus 2i. Now powers of I, we can't leave I to a power greater than 1, but I squared is negative 1. Now our 3 times negative 1 would be positive 3. And 8 plus 3 is 11. So our final answer is going to be 11 plus 2i. Now we could also do these in the graphing calculator, because we could say 2 minus I times 4 plus 3i, and it'll give us the exact same answer. So if we look at this one here, 3 plus 2i times 3 minus 2i. Well, our 3 times 3 would give us 9. 3 times negative 2i would be negative 6i. 2i times 3 would be plus 6i. And lastly, 2i times negative 2i is going to be negative 4i squared. Now we combine like terms. Negative 6i plus 6i is going to give us 0. Negative I squared, or I squared is going to be negative 1. Now our negative 4 times negative 1 is going to give us positive 4, telling us that this here reduces to 13. So here we multiplied actually by the complex conjugates. And when we multiply complex conjugates together, we will get a number that does not contain I. And the last example that we have is 3 plus 2i squared. And again, we can do these by hand, but the graphing calculator will do these for us too. So 3 plus 2i squared is going to be 5 plus 12i. Complex conjugates. This occurs when a pair of complex numbers of the form a plus bi and a minus bi. These are complex conjugates. We flip the sign in front of the term with I. So if we wanted to find the complex conjugate of 9 plus 2i, we would flip the sign in front of the I term, telling us that its complex conjugate would be what? 9 is 2i. And if we want to find their product, all we've got to do is multiply the two together. And when we multiply complex conjugates together, we will get a number without I. We'll get a single number. 9 times 9 is going to be 81. 9 times negative 2i is going to be negative 18i. 2i times 9 is going to be plus 18i. And 2i times negative 2i is going to be negative 4i squared. Well, negative 18i plus 18i gives us 0. And again, I squared is negative 1. So we're really saying that we have 81 plus 4, telling us that their product is 85. So the complex conjugate was 9 minus 2i, and their product was 85. Now for the other example here, we got the square root of negative 20, so we can't just start by flipping the sign. We actually have to simplify this first. Now we know the negative is going to come out as I, leaving us with the square root of 20. And the square root of 20 is 2 square root of 5. So for us here, it means that in simplified terms, the square root of negative 20 is 2i square root of 5. This also means that its complex conjugate is negative 2i square root of 5 because we're switching the sign in front of I. And if we want to find this product, we're just going to multiply 2i square root of 5 by negative 2i square root of 5. Now our 2i times negative 2i is going to be negative 4i squared times. Now the square root of 5 times the square root of 5, we could say that is the square root of 5 squared. But the square root and the square will cancel, leaving us with just 5. Also, the square root of I, or it's not square root, I squared is still negative 1. So negative 4 times negative 1 is 4 times 5 is 20. Questions on this here? Now, to simplify rational expressions, we would use the complex conjugate of the denominator, multiply it on top and bottom, to get rid of the i's out of the bottom of the fraction. Now for this here, what that means for us is that we have to multiply the top and bottom of this fraction by the conjugate, or the complex conjugate of the bottom. Since 4 minus 2i is on bottom, we're going to have to multiply by 4 plus 2i on top and bottom. And as we multiply this out, on bottom, we're going to have 4 times 4, which is 16. 4 times 2i is going to be plus 8i. Negative 2i times 4 is going to be negative 8i. And negative 2i times 2i is going to be negative 4i squared. On top, we're going to have to do a similar distributing. 2 times 4 is going to give us 8. 2 times 2i is going to give us plus 4i. 3i times 4 is going to be plus 12i. And lastly, 3i times 2i is going to be plus 6i squared. And again, at this point, we can start simplifying. We have our 8. Now our 4i plus 12i is going to be plus 16i. Plus 6 times negative 1. On bottom, we still have the 16, but our 8i, negative 8i is going to become 0. And just like above, I squared is negative 1, giving us 4 times negative 1. So on bottom, that negative 4 times negative 1 is really just going to be plus 4. On top, we still have our 8, but our 6 times negative 1 is going to be negative 6, plus our 16i. Now 8 minus 6 is 2, plus 16i over 20. Now all three terms do have a common factor of 2 that can be reduced. And if we reduce that 2 out of the top, we get 1 plus 8i over 10. Then we could technically split that fraction into 2 fractions. And if we did that, we'd have 1 over 10 plus 8 over 10i. Now the 1 over 10 doesn't reduce, but the 8 over 10 does have a common factor of 2, which would reduce to 4/5 I. Questions on this here? There we go. Now, there are other ways that we could have done this. Because one of them is multiplying like we just did, and going through this here, and it's pretty much the exact same thing we got. The other is alpha y equals enter 2 plus 3. I don't know what it is. 2 plus 3i over 4 minus 2i. And we get our answer. Either way works. Both get us to the same spot. Questions on this here? Solving quadratic equations. You can write a number such as square root of negative 3 in standard form by factoring out the I, the square root of negative 1, and simplifying where needed. When a is a positive real number, the principal square root of negative a is defined as this here. Just simplifying what we've been doing. So in terms of just simplifying, square root of negative 6 times the square root of negative 2, well, the negative in both of these cases is going to come out as I. So really what this is saying is that I have I times the square root of 6, I squared of 6 times I square root of 2. Now here the I times I outside will multiply to give us I squared. Square root of 6 times the square root of 2 would give us the square root of 12. Now, as we said already, I squared is negative 1. And we do need to make sure that the square root of 12 doesn't reduce, and it does. And it reduces to 2 square root of 3. And if we multiply these together, we'll get negative 2 square roots of 3. And we can see a similar process with this here. Negative square root of negative 8 plus the square root of negative 50. Again, with the negative 8 we can bring the negative out as I, and then we will need to simplify our radical, the square root of 8. We can do a similar process with the square root of 50. We can start off by taking out the I. Now the square root of 8 is going to reduce to 2 square roots of 2, because 8 is going to be 4 times 2. Square root of 4 is 2, so it comes out. We leave the 2. Square root of 50 is going to become 5 square roots of 2. Because for us, 50 is the same as 2 times 25. Our square root of 25 is 5, so it comes out. 2 stays inside. Now, since both of these have I square roots of 2, we can actually add these together, giving us 7I square roots of 2. That is our answer. Questions on this here? Last thing we're going to do is solve this here using the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, our a, b, and c come from the general form here. So for us here, a is going to be 3. B is negative 2, and c is 5. So as we plug this in for this here, we'd have x is equal to negative our b value, which is negative 2. Plus or minus the square root of b squared, so negative 2 squared, minus 4 times a times c all over 2a. So using the quadratic formula, even though we're going to get complex solutions, it's still going to work the same way. Now at this point here, we have our negative 2. Well, negative 2 is positive 2. On bottom, 2 times 3 is 6. Now at this point here, we can plug everything inside the radical into the calculator. So we can say negative 2 squared minus 4 times 3 times 5, which gives us negative 56. Now we still need to reduce this as far as we possibly can go. Now negative 56, the yellow calculator, the 30xs, can't take the square root of negative 56. It can't do negatives. But we know that this negative is going to come out as I. So really what we have left over is the square root of 56. So if we look at the square root of 56, it is 2 square root of 14. So the square root of negative 56 is going to be 2I square root of 14. Questions on this here? Is there a number in common on both of the numbers on top and the bottom? Yes, 2. Because if there's a number in common in all 3 spots here, we do need to remove it from the top and bottom. When I factor a 2 out of the 2 2's on top, they both turn into 1. So if there's no other number with the first 2, it's just going to be 1. We could write 1I square root of 14, but that's the same as I square root of 14. And the 6 on bottom is going to reduce to 3. But that's it. Questions on this here? And they did the exact same thing. They split it up, but we can leave it as one whole. And that's it for 2, 4.